Oh, now there's a fun topic for discussion. Radioactive waste produced by burning fossil fuels. Well, radioactivity is ubiquitous. Uranium, thorium, potassium, and their decay products, they're all in the earth, always have been, always will be. And so we get over 300 milligram a year just from natural radioactivity all by itself. Most of that's from radon, which is, uranium and thorium decay product. But when we're talking about coal, the source of the radioactivity, again, is that same source. Now, uranium, it's about 3 parts per million in any amount of dirt. Thorium, it's about 9 parts per million in any random sample of dirt. And you can get that in coal. And so what ends up happening is that if you look at the amount of radioactivity in the coal ash and that goes up the effluent through the coal stacks, as a function of energy, you can actually get some coal where you actually generate more radioactive waste per energy if you burn coal than if you do nuclear energy. Now that might sound crazy. Well, how does that happen? It just comes back down to the physics, to the actual science here. Now let's walk through the math in a very user-friendly way here. If I'm doing combustion of fossil fuels, for all the molecules that are present, the water and the carbon dioxide output, and then the graphite and the oxygen input, every time I have a complete reaction, I get about 1 electron volt of energy per atom that's taking part in that chemical process. And that's just burning fossil fuels, about 1 electron volt per atom. Now, if I'm fissioning uranium-235, I get about 200 million electron volts for one fissioning of a uranium atom. So that's 200 million times more energy per atom. And so if I have 3 parts per million of uranium in coal, then that means that by the time I've done 3 million atoms of coal, I have about 3 uranium atoms that's going to be in that coal ash, along with all of its decay products. And so there's still a difference of over about a factor of 100 here, so that I can actually start creating a lot more uranium and its decay products in the ash per energy output from the coal than I got from nuclear. Nuclear is just that energy dense. There's just that much energy that comes from fissioning a nucleus. And so, yeah, it's possible for certain coal to give you much higher radioactivity per energy from burning fossil fuels than you get for doing fission with nuclear reactors for commercial electricity production. So, great question. Thanks for watching. Have a good day. Bye.